So this lesson here, we're going to take a look at, learning goal 28, we're going to be taking a look at fractional coefficients in linear equations. So what we've been doing so far is we've always just taken a look at what happens if we have a number. Okay, how do we get rid of that number in front? But we're going to take a look at what happens if we throw a fraction in front. What are some of the ways that we can use fractions in our equations? Now, the first thing to kind of go over, and we're going to start with this here, is that a fraction is a rational number which can be described as a division statement between two integers. And when I say integers, it's because we could have negative numbers in there as well. A negative number in a fraction will make the entire fraction negative. Two negative numbers would make it positive because it's a division statement. Now, something that's important that we recognize is that the denominator cannot be zero. So if we have something in the a value of x in the denominator or a value of a number in the denominator that's zero, that's just not going to work. Okay, so we can't have a zero in there. So that's just one thing to be reminded of when we're going through our questions. Now, a fraction can be described as a decimal, but is more accurate when left as a fraction. When we're solving an equation. Okay, so if we keep it as a fraction, it'll be more accurate. If we change it into a decimal, if that fraction isn't a has some sort of non-repeating or non-ending decimal, or we can't put the entire repeating signal into our calculators, we're going to have an error when we come up with our final answer. Okay, and now that error might be very small. Okay, it might be not overly big, but it will still be inaccurate, and we need to make sure that we want to keep the accuracy in there, and fractions do that. Fractions keep things as accurate as possible. Now, as I mentioned, rounding the decimal can lead to small differences, which result in inaccurate answers. Okay, and that's why we want to try to keep things as accurate as possible. We want to keep the fractions and use fractions in our calculations. Now, fractions can be used instead of integers as coefficients of a term in a linear equation. All right, so that's just a little bit of a basics on fractions. Now, let's solve equations using fractional coefficients. A term which has a coefficient represents a multiplication statement between the coefficient and the variable. Variable, there we go. Let's make sure to spell it right. Or variables, okay, I'll put an S in there. We could also have like multiple variables. Often it's just one, but we could have multiple variables as well. Now to remove the coefficient, okay, we divide, so this is what we've done in the past, we divide all the terms by the same, in this case it would be fraction. Okay, often we would just do a number, but here we're actually going to do a fraction due to the fact that our coefficient is a fraction. So we divide them all by the coefficient. Wow, this can be a challenge. Multiplying each term by the denominator will remove or simplify. I'm going to use the term eliminate. Going to eliminate the fraction, and I'll show you how in just a little, or in this first example here. So let's solve the following equation. We have 4 is equal to 2 over 3x. When we talk about solving an equation, we're talking about solving for what value of x makes this work. Okay, which value of x can we put in here so that this whole thing is going to work out? Now, the first thing that we do is we want to get rid of that fraction. So that fraction is being multiplied to x, so we want to divide by that fraction. Now that can be a challenge, especially if we're not using calculators for it, or if your calculator doesn't have a fraction button, which we may or may not talk about in class. But to get rid of that fraction, the one thing we can do is we can multiply by the denominator. So we're going to first determine the lowest common denominator of all the fractions in the equation. Okay, so we're going to determine the lowest common denominator of all the fractions in the denominator, or in the equation. Now you may notice here that this one has only the one fraction. Okay, so all we're going to do is we're going to take the denominator of this fraction. In that case, it's 3. Okay, so our lowest common denominator in this case is 3. Then our next step, and I'll just do a different color here, is we are going to multiply each term by the common denominator. What this is going to do is this will eliminate all fractions in the equation. Now here again, we only have the 1, so really all we're doing is we're getting rid of this fraction right here, but we are going to multiply this term by 3, and we're going to multiply this term by 3. Now in this case here, we look at what's 3 divided by 3, it's 1, so technically we're just multiplying the 2 by 1. And here, well, there's no denominator, so you don't have to worry about that. But that's what we're doing. So if we have a denominator bigger than this, or if we're multiplying by something bigger than the denominator, we divide. So we'll take whatever we're multiplying by and divide by 3, and then we'll multiply it to the 2. Now, again, we can do that in different ways as well, but if we have the same number, it's fairly straightforward. 4 times 3 is 12, and 2/3 times 3 is going to be 2, and it's going to be x. So that's how we get rid of the denominator. Now you notice there's no more denominator. That's gone. Okay? We still have a number in front of x, but the denominator part is gone. So finally, we're going to solve the equation for the missing or blank variable. So now we can solve for x. Now in this case here, solving for x is going to mean that we are dividing both sides by 2. Okay, and remember we divide by 2 because to get rid of this, we need to divide by the same value. So we divide by 2, that's going to isolate x. Remember when we talk about isolating x, we're talking about getting rid of anything around x, getting it all by itself. 12 divided by 2 is 6, and so that tells us that x equals to 6. X equals 6. That is our final value in this case here. So we start off by multiplying by the denominator, and that removes the denominator, and then we divide by whatever's in front of x to get it all by itself. And so that is important that we see. Now, if there is a constant on the side of the variable, okay, so if there's a constant on the side of the variable, like we have right here, okay, we have this -5 as a constant, what we're going to have to do is move it to the other side by adding the opposite to both sides. Okay, so we're going to move it to the other side by adding the opposite to both sides. Now, in this case here, we have a -5, so we're adding +5. If we had a positive, we'd be adding a -5. It's the same as adding or subtracting, so we're just doing the opposite function or opposite operation to move it over to the other side. We do that first, then we go through all of our everything else. So the reason for doing that is if we were to multiply everything by 2 here, then we would have to multiply the 5 by 2 and the -2 by 2. Instead, we're going to just move this number over first. We want to get the x term all by itself. So when you do that, this is going to cancel out. So we have -2 plus 5, which is going to be +3. And this is going to equal -3/2 x. Okay, so it equals -3/2 x. Now, there is a couple different ways we can do this. Let's just deal with the positives for the time being here. We'll try to make it as simple as possible. It's going to be our goal. We have a 2 as the denominator here, and we have nothing here. So we're going to multiply both sides by 2. Okay, so we're going to multiply both sides by 2, which is going to eliminate those, and we're just going to get -3x on this side. So when we multiply by 2, 3 times 2 is 6, and that's going to equal negative 3x. All right, so we're slowly working our way to get our x value all by itself, kind of working from the outside, coming in. All right, final step. Let's divide this side by negative 3, and we're going to divide this side by negative 3. Okay, now the reason we do the negative is because there's a negative there, so we need to cancel out the negative as well. I'm going to put this right here on the bottom. So 6 divided by negative 3 is negative 2. And negative 3 divided by negative 3 is 1. So we're just left with x. That tells us that our x value is equal to negative 2. So that was our whole goal in finding that. We figured out what our x value was. Now, I want you to work on questions 1 through 4. Questions 1 through 4 deal with exactly what we've just been talking about in this video, just solving for our x value.